So you've done it. You've spent all that time building the perfect conceptual data model. It's logical, it's clean, everyone's signed off on it. Awesome. But now, how do you actually turn that beautiful blueprint into a real working database? That's the leap we're going to break down today. Let's dive in. This is a question that trips a lot of people up. You've got this super detailed data model. So, that's the database design, right? Well, you might be surprised to hear the answer is a clear no. They are two very different things, even though they're super closely related.
You know, the easiest way to think about it is with this analogy. A data model, that's the architect's blueprint for a house. It shows you all the rooms, how they connect, the whole big picture concept. But the database design, that's the detailed construction plan. It tells you exactly what kind of nails to use, the thickness of the drywall, the exact measurements. One is the what, and the other is the how.
So, to get from that blueprint to a solid plan, we're going to walk through 4 key things. First, we'll look at the overall roadmap. Then, we'll get practical and talk about turning entities into tables. After that, we'll get into the really crucial art of choosing keys. And we'll wrap it all up by talking about designing with a clear purpose. Okay, so what is that roadmap? The good news is, you don't have to guess. There's a really clear, structured process you can follow to make sure you get this right.
That's right. In fact, this whole sometimes complicated-sounding transformation, it really just boils down to 3 essential tasks. And here they are. First, you take your conceptual entities and turn them into actual, concrete tables. Second, you use foreign keys to build the relationships between all those tables. And third, you use constraints to enforce your business rules. Now, for this explainer, we're really going to focus in on that all-important first step and the art of keys, because that's the foundation for everything else.
All right, let's start with task number 1. This is truly the foundation of our entire database. It's the moment where our abstract model starts to become a physical reality.
So let's use a real-world example. In your data model, you've got this idea, this entity called employee, and it has attributes like their number, name, and department. How does that abstract concept become something a database can actually understand and work with?
Well, the translation is surprisingly direct. Your employee entity, that becomes a table. Every attribute, like first name or department, that becomes a column. But right here is where you start making some really critical design choices. You have to assign a specific data type to every column. Is it a number? Is it text? And, probably most important of all, you have to pick a primary key that's going to uniquely identify every single employee.
And that leads us perfectly into what I think is one of the most important parts of database design, choosing your keys. This is not just some technical detail, folks. This is absolutely fundamental to making sure your data is reliable, accurate, and that your database performs the way it's supposed to. Now, you might be thinking, choosing a primary key is easy, right? Just pick a column that has unique values, and you're good to go. But is that really enough? What's the difference between a key that just works and one that is truly ideal?
An ideal primary key really has 3 main characteristics. It should be short and numeric, because databases are just ridiculously fast and efficient at indexing and searching numbers. But the big one, the most important one, is that it has to be fixed. It should never, ever change. Why? Because if a primary key changes, you could break every single relationship connected to that record. That is a recipe for disaster.
So this brings you to a major decision point between 2 types of keys. You've got natural keys, which are made up of attributes that already exist in the real world. Think of combining a street, city, and zip code. On the other hand, you have surrogate keys. These are totally artificial. They're just numbers, like an auto-incrementing ID, that have 0 business meaning. Their only job is to be the primary key. So when would you use a surrogate key? Well, you use it precisely when your natural key option violates those ideal characteristics we just talked about. I mean, think about that full address key. It's long, it's all text, and parts of it could actually change if a street gets renamed. It's large and unwieldy. In pretty much all of those cases, adding a simple, numeric, never-changing surrogate key is the far better design choice.
Okay, one last thing on keys. Alternate keys. So any column that could have been the primary key is called a candidate key. Once you've chosen your primary key, the other candidates can be marked as alternate keys. Let's say we use a simple employee ID as our primary key. We can still set the email address column as an alternate key. What this does is it tells the database, hey, whatever you do, do not let 2 employees have the same email address. It's a great way to enforce critical business rules.
So as we start to pull all of this together, I hope you can see that transforming a data model isn't just some random activity. It's a very deliberate step-by-step process that takes us from that high-level blueprint to a detailed construction plan that we can actually build from. All right, let's just do a quick recap of the big takeaways. First, always remember that difference. The model is the concept, the design is the plan. Second, this transformation is a structured process, and it starts with the foundational steps we talked about today. Third, that first part, turning entities into tables, is a pretty direct one-to-one translation. And finally, be so deliberate when you choose your keys. A great key is really the cornerstone of a solid, stable database. So, what's really at stake here? What's the big risk if you get this design wrong? It all comes down to avoiding something called modification anomalies. See, with a poor design, a simple action like updating a department name could accidentally corrupt thousands of records. Or deleting one entry could unintentionally wipe out a bunch of other critical information you needed. That's why being this deliberate during the design phase is so incredibly important.
I really hope this breakdown helps you turn your next data model into a truly world-class database design. If you found this helpful, do me a favor and hit that like button, share it with someone who might need it, and of course, subscribe for more practical explainers just like this one. Thanks for watching.